Good afternoon. I'm happy you have chosen to stay at networking track. And as there are 10 kinds of people, those who understand binary and those who not, there are also some kinds of people who use BGP or hack it. And from the smile in your face, I see that we have both groups presented here. So my name has not changed. I'm still Andis Arins, and I like to think of myself as, even if you see I'm coming from previous century, I like to think of myself as a young scientist. And hopefully this is the very last year for me as the PhD student in University of Latvia. I'm studying the future internet research, and my thesis is also about BGP and future internet possibilities. And sometimes I say that with one leg I'm in academic field and with another leg I'm in commercial networking. So I'm also working with European Union internet researching projects as the review expert there, and also as a board member in Latvian Internet Association. And as I said, with the second leg I'm in a commercial networking. Recently I visited Malaysia Telecom. They said we have a small network, just 20 million connections. We want to do some projects here. So basically my main areas in commercial networking are microtic networks, especially together with combination with Cisco equipment. And I'm also a Microsoft certified trainer. So as I said, today we will speak about some quite wide network aspects in internetworking level. And I would like to start with a case study. Maybe some of you remember. It happened on April 26. Actually, it was Latvian time. It was a very early morning, April 27. And what happened was a list of networks were hijacked. I'll explain the name of hijacking a bit later. What was the most important for us was that in the list there were also 2 Latvian commercial banks. You can see one of them here. The second one didn't pay for advertisements, is not yet here. Here are also some references. If you are interested, you can go deeper and read what's happened there. But before we begin in the case study, just to switch your attention from Pokemons in the previous presentation to autonomous systems, here in our study, I would like to ask you a question. We have also a very nice prize fund, 10,000 BGP updates from CERT and this nice box from me. So we know, at least those who have heard, that there exists autonomous systems which allow you to play with larger possibilities in internetworking between operators in the network. As I mentioned, there were 2 Latvian banks influenced. The question is, according to CERT.LV information, how many Latvian banks actually has their own AS number? So either the one who will tell or will be the closest has a small switching price to start thinking of autonomous systems. So 10? 15? 6? Not yet. Today is not your best day to go to casino downstairs, but maybe someone is maybe more lucky. Just 3 last guesses. So there was 4, 2, and 20-something. 15 was the closest. Actually, the right answer is 17. So this is for you. You can share. Who said 15? There was something. That's going to you. Thank you. So now, if we look back in the diagram, this is how it should work normally. So either your organization or your service provider has a thing which is called autonomous system. Actually, you can register one in the RIPE or ask your ISP to do it. And the autonomous system can hold either one or multiple network prefixes, like here in example we see for Norvik Bank, which starts with 194. One autonomous system can have either a single prefix or a lot of prefixes. The larger player in the world is Chinese educational organization with more than 5,000 such prefixes. If we look back here in Latvia, the largest player, La Telecom, has something a bit over 500 such prefixes. So you could a bit step back some steps, and if you remember, like configuring your PC and assigning IP address, there is a thing as a gateway. Either you do it manually or DHCP server provides it to you, but the gateway actually is the one which will bring your packet to the destination. This is something like in relay. We know that Usain Bolt is very good in relay for running. Here for routers, to actually pass the packet to the destination, they have to do it much more quicker, otherwise you would throw them out. So here, it cannot happen very long as in approach as you do it on the PC. So you set a gateway, your gateway has a gateway, and so we cannot continue too much. So in one moment there comes in a router which has a BGP protocol enabled. Usually, if it's not like your own edge router, it happens on your ISP edge router. And what the ISP has to do here, and if we look now on the Norvik side, so here, so it has to pass the BGP update either to its one or multiple upstream providers. Their task here is to redistribute this update to their neighbors, and so on. Usually it happens in some 5 to 10 steps until we reach all possible routers who speak BGP in the world. So if we look just on the time window, it's on average less than 1 minute from here to reach Australia. So Norvik started to announce something. It went to the first ISP and also to the second. These guys redistributed next. So finally, it's reached at another side. And also the same process has to happen from remote side. Later we'll look on the list. Here you can already guess one of the destinations about which we will speak, and that's a MasterCard, so credit card processing enterprise, which actually was involved also in this incident. And also they have to know the path backwards to our local Norvik bank. And it happens normally using BGP, and it works so actually in the whole worldwide network. This is one aspect where I would like to emphasize that from some kind of perspective, and with BGP it's always important from which kind of perspective you look on it. This is the same as the question about those two scientists. So how many scientists we need to screw a bulb, a light bulb? So just two, one who holds the bulb and the second one who rotates the universe. So you can get it in. So also here for BGP, now it's a question about from which perspective we look on those routes. Here with BGP is that our announcement, what we send out to others, it brings the traffic back to us. So we teach all other ISPs who has autonomous system AS in the world. At the moment, the latest data, there are around 59,000 such ASs in the world. So just to understand the scale, and around 700,000 those prefixes. This is what the routers has to process daily, those which are like the big edge routers in the ISPs. So a lot of ASs and a lot of prefixes. And here the key thing in BGP, and actually it's one of its weaknesses also, what was designed those 20 plus years ago, and these scientists who did it actually didn't take into account that in the year 2017 we have that much BGP players in the world. What they didn't think of, actually correctly from our today's understanding, is the security about prefix propagation. So where's the problem? In the core, everything is based on the trust. So if one of the ISPs said, I have the network of Norvik Bank, others, large players, usually believe it. And they are rechecking their existing routing information to the new one and comparing. Did we receive a better route, as it happened during the incident via the Rostelecom, or the existing one is the best? So that's the basic approach. There are more than 10 steps in the BGP algorithm how it actually evaluates, but one of the most important things is how many autonomous systems are in the path. So from the source to destination. We don't care how many routers are or switches are within one autonomous system, just how many ASs are there. So that's how it should work normally. Now, what happened during the incident? This is an X-ray just from the BGP prefix announcement pool. Here actually is also a link using the RIPE tools how you can generate such for your own networks based on your IP addresses. If you like to do research how your own AS looks like from outside, here's an example how to do it. But what we see here, and this 61100, that's a number of Norvik Bank. It has two connections with AS12578, this is Latvian Telecom, and another one, 21156. Usually it's good that you have two or more upstream providers. If one of them fail, or you do some maintenance, you have the second one through which you can still reach the world and provide your services. And if you decide to fire one of those and take a new one, you don't need to renumber, so IP addresses stay the same. If we do a trace, and here's an example for the normal path from Norvik to MasterCard, you see now some parts of the trace route. There's a part in the red. This is the first upstream provider of Latvian Telecom, NTT, towards the MasterCard. And in the yellow, that's Akamai Technologies, actually also a large service provider, which is connected to the final destination, which is MasterCard. So this is how it should look normally. There are some 9, I would say 10 steps to the MasterCard network, and just 3 ASs in the transit. If you look from BGP perspective, that's how it looks if you look on BGP level. So here you don't see any more those trace route hops, but just autonomous systems. And usually you have multiple paths to the destination. They can change, it's normal. There happens things also on international networks, they change, but that's how the stable one looks like. Also here I present a list of, and also the source from where the list is coming, with those 36 affected prefixes, and I have highlighted here some most interesting for us in the red color. So what happened with the whole list, including also those in the red? So in evening of April 26th, Greenwich time, a new AS started to announce these networks, and this AS is 12389. You can guess it's Rostelecom. And they started to announce and claim, we have now also these networks. The problem was now these networks overlap with existing, and BGP needs now to recalculate if these, what we received now, are better networks than what we have or no. And for the part of the internet, actually this happens on the region which is AS-wise closer to attacker, and at the moment the attacker is AS12389, and the victims is this list of 36 prefixes. So those who are located closer to attacker, there's a larger probability for them to get influence from this incident. And so it happened. So once again, going back to Norvik Bank perspective, It receives now hacked BGP injections, or we can now say that here the BGP hijacking happens because an AS, which is actually not allowed to announce this network, does it. So these prefixes travel, and not only to Latvian Telecom and the second operator data group, but also to others around Rostelecom, and those affected networks now start sending the real traffic to Rostelecom. The Rostelecom is a different company than what you heard recently. Another Russian operator is providing now a transit service for North Korea. This is a different one. Also coming from Russia, this is Transtelecom. This is Rostelecom. So a different story. But anyway, so going through this 6939, what you see above the red cloud, that's a Hurricane Electric, which has a pass to Latvian Telecom. And 20764, which is below the red cloud, it's Rascom, also another Russian operator. Actually, it was a kind of brutal attack because those who did it, and it's also not very clear till now, either it was a direct attack or some misconfiguration or some fail of administrator. For me, it looks more like attack because this list mostly contains the financial players. This is like an argument why it should why it looks more like attack than just a fail of administrator. So if you look a bit below, the hijacked AS pass now from Norvik to MasterCard was just 2 ASs to go through Latvian Telecom, and now, depending what the Hurricane Electric does, either it's also in the transit AS, as you see on the right side, or Rostelecom, if it can peer with Latvian Telecom directly, could make the pass even shorter. So why brutal? Brutal because now the originating AS, if you look on the numbers, is different than it was before. So before it was 26380, now it's 12380. If the Rostelecom did it in more smooth way, like if you look on the last line, so if you hack BGPs, but I don't suggest you to do it, otherwise CERT will hunt you down. But anyway, this is much more difficult to fight against if in the end of the AS pass you have the real AS number of the originating AS. But this is what happened during the incident. The incident was for around 7 minutes. Then Rostelecom withdrew its update, and the network converged back. So what was the impact of such incident? First of all, on some region of the network, I would say Eastern Europe, and maybe also Scandinavia and whole Russia influenced, the packets which were sent both to Norvik and MasterCard arrived at Rostelecom network. If these communications are encrypted, still then the attacker has some hints now about the packet rate, who is sending whom, how often, and so on. Even they cannot decrypt the contents, it's still some valuable information if they plan to do the attack later. Now, I would like to look also next what we can do if our network actually gets in the situation as the Norvik Bank was in. So if I had an artificial intelligence like in my calendar, I would expect from it just to have a hint, go on vacation 2 days before it happens. So it's not an easy time for anyone if your network is hijacked and you need to fight to get it back. So here, luckily, it solved, the situation solved itself. So the administrators of Norvik and DNB directly didn't had like to fight with Rostelecoms or go to cut the cables or some brutal actions or legal ones through the CERT organizations. But if the situation didn't stop, the only first thing they can do is come with a claim. And now In the first morning presentations, we also heard, we can go to CERT and ask to help to solve such situations. So from another side, I would say that if your prefix is hijacked, it's too late. Well, there are also some steps what you can do before it gets hijacked. And now, if you have your own AS, it also is a message to you. If you don't, it's a message to your ISP, but you can encourage them also to look on these things. Luckily, such hijacks on BGP level don't happen very often. That's a good news. The bad news is if it happens, for sure you will be in all media if you are a large player. And this is what you don't want to achieve here. So it's better to follow the methods which are available. So we have 5 of them. Let's go quickly through. So on the first peering level, this is what usually happens. You can protect the peering messages with MD5 hashes, but this is only on the edge between 2 ASs. And usually it happens, so it prevents that someone cannot come in the middle here and start sending some BGP updates to mislead your network. Actually, it's quite typical BGP attack to come in the middle here, but then it has to be between 2 players here. The next one, and this is also very popular and works nice, and usually happens on the edge between the BGP customer and the first tier of transit ISP. So here, the largest player, usually like here Latvian Telecom, filters what's allowed to come from Norvik Bank, and everything else is discarded. So also works nice. From the Norvik side, the filtering actually has to be done more widely. If Norvik said, I want to see only Latvian Telecom networks, the same approach here back, then the Norvik network can reach only Latvian Telecom. It's not enough, so they need to reach MasterCard and other networks. So usually they accept everything, including hijacked BGP updates, which came from the Rostelecom here. The third, okay, also sometimes we combine IP prefix filtering with some databases. Either it's a regional internet registry like RIPE in Europe database or some peering DBs, but here, and also you can look in an example for the Norvik, they can claim what they would like to import and what they are announcing to their peers. So that's also a good matrix where to look in and use it for the filters on the peers. But once again, usually this happens on the edge level, so between the customer and the first tier of provider. In the core, they accept anything from anyone. And this is the weakness of the BGP. Here's also a tool where you can look if the network is registered in some registries. And then we go to force one. So if this one was implemented for Norvik, possibly they would survive. So it's called resource public key infrastructure. It's not that easy to configure it, but it consists of routing origin authorizations, which includes AS number, address range, and prefix length. So if you do it, and for Europe you do it in the RIPE, and others take it in account, you have a large chance to survive in such situations. It's similar somewhere in its nature what you have open SPF for the mails. So everyone can claim from where it's coming, but this one also has some signatures. Here's an example. So this is how it would look for the Norvik Bank. If the length is not specified, then it has a direct match for the prefix. So only 2 of, as we guessed, 17 Latvian banks has this RAW implemented. The bank on the left one, multi-bank, this is located just, if you go out from our hotel and cross the street, Elizabeth 57. So the closest building from here, they have done it. And there's another bank with AS41333 who has configured it, but they don't match actually what they announce. So usually they might get discarded in the world, from those parties who follow the ROA approach. Others have not implemented it at all. It looks like from the pattern that both those prefixes are a smaller part of the Telia Latvia, which actually has done the job for them. But if the Nordic had it in an action, possibly they could survive here. There's only one ROA weakness. If the attacker, and this is what I emphasized also in the slide where the hijacking took place, places the AS number in the end, or even on the hijacked route, it will still go through. So that's the weakness for ROA. The last thing which could be implemented, it was for 2 last years in the draft version, now since September 2017, so just a few days. It's an official RFC document. Only very few players in the software perspective follow it and support it. But the BGP SEC supports the whole AS pass from source to destination as it's digitally signed. Similar to ROA, but now each step is signed. The weakness of this method is that anyone in the transit has to support it. So all ASs, if they decide and start supporting it, no such hijacks can happen anymore. So it's a question of the software updates, possibly also the hardware update, and finally some downtime or maintenance windows to do it. So if someone in the world can convince anyone to do it, we don't speak anymore of direct BGP hijacks. So what we do and what is my research, and as the scientists, you see, we need to come with some new proposals, something what hasn't been yet. Then we do some testing, experimenting, then we compare the results. Not always the discovered results are better if you compare with what was there. Sometimes you try to find what's better because it's good for academics to have some improvements. So here we experiment with some hybrid method between 4 and 5 where we SYN update itself. Not the resources which are stored in the RIPE database, but the update itself. And the BGP update travels together with the digital signature. We are experimenting with 2 clouds where to place, because anyway, when you receive an update, either it comes with a signature or it's just a pure update. To judge now it's a good update or bad update, you need to compare it with something. So here, our proposal is to keep the second part, so the public key, and we were experimenting to do it, first of all, in DNS as recursive address ARPA level. It works. Now we are working to improve the latencies here, but at least we have succeeded that the approach is working. And the second approach would be the RIPE or Regional Internet Registry database. So that's our method. We are experimenting in it. If you are interested, you can also try and come with the method. So for today, that's it from my side. I hope you found the case interesting, and also you have some steps against which you can evaluate your own BGP security. Thank you.
Thank you for your presentation. Do we have some questions?
How you did detect that there is hijack? No, there is a problem with hijacking.
So as I said, this hijack was quite easy one for detection. If you want to follow just the all BGP hijacks, and each day there are some hijacks, this was like a large scale, you can go to bgpstream.com, but also if you have a BGP peering with one of the players in the cloud, anyone, you can pick one of 59,000. Then when you receive the updates, you can always compare with what you have stored in the database. So if there is a change, always there is a small chance that that's a hijack. Not always it will be a hijack, but there's a chance that it is. So also here it was detected as the large scale of the networks suddenly changed. So this is how they detected.
question regarding if some hybrid war occurs, what is steps to prevent some data data flows, which would be very.
Okay, thank you for the question. So there are two methods basically. Let's assume that you have done a homework and all these rows are there and you can legally prove that that's your network. One of the methods is to start announcing more specific routes. Here for the Norvik it was a bad case because /24, which is like 255.255.255.0, is considered normally on the worldwide networks to be the smallest one. If you had a larger network, you could just split it and it would be more specific. There have been some cases where the /24 is hijacked, and to solve it at least regionally, you can try to negotiate with local providers around you to accept /25 from you. So this is one of the possibilities to survive. The second thing is that you can actually negotiate with some other anti-hijacking or DDoSing partner. The same thing happens also in the DDoS. When someone is sending a flood of 10 terabits to your network, for sure you will be down. So what happens, you can ask someone else who has much more power also to start announcing, actually legally, to hijack your network and then route the whole network through them. So this is the second option, you can do it. But for both of them, you need to do homework before. So to have a plan, backup plan, as we can go and speak with them directly and they know why you ask it. So you have prepared the plan before. Thank you.
Let's have another question.
Talking about the BGP hijacking. As you know, if you are planning to hijack the traffic, you need to prepare the processing of the replays of all of the packets. So if you are talking about the hijacking, if it would be usual admin mistake in the BGP configuration, the traffic what were rerouted through the another one BGP peer actually would be dropped or died with the usual packet time for leave. But if we are talking about the hijacking, so your infrastructure should be prepared completely to forward the packets back to the original destination.
Thank you for the question. So here are two possible impacts from attacker's side. One thing is with the hijacking, it spoiled the service availability of the victim. This is one. The second about what you speak is that the hijacker, so attacker, stole the traffic. The traffic still works fine, but the attacker can capture it. So both of them are considered as the BGP hijacking. And sometimes you are able to hijack just one direction of the traffic. The second one actually is coming back differently. So here the Rostelecom was actually strategically in good place as it's somewhere in the middle between the Norvik and the MasterCard. If these guys had a direct peering, the Norvik cannot attack them. So also a good note to think of, if you have important partners, try to peer with them directly. Then such hijackers directly won't attack you. Thank you.
So let's have one more question, and then the end.
Thank you. What are the consequences when someone hijacks in such a scenario network? So in general, as we can see from public, there is just notes in the media, maybe some handshaking maybe, or I don't know. It's kind of, we can detect such hijacks, we can identify who is hijacking, basically, I believe. But what are the next steps?
Okay, so it depends, once again, of the perspective of the person or institution or organization you ask. If we look on the guy who maybe configured the code in Rostelecom, possibly he had a bonus prize from his management as he succeeded his task. From our side, as just a global players, we can do nothing. we are connected to the internet, we can just take some lessons. So the consequences is that we speak here about it today. But otherwise, if I was now asking every one of you to send some gigabytes of data for them just to take thank you, it would be already a wrong, the wrong way of me of doing that. So we cannot, so if your question maybe is something like, should we respond or hit back? Actually, we are not allowed to do it.
Hello, I'm Kaur from a bank, unidentified. So I watched this, I'm now panicking. Can I come to you? Can I tell you my BGP pairings and routes and ask you to watch my BGP for me? And of course, I'm offering you money. Will you take my money? And if you won't, will somebody else do? Will somebody watch my BGP for me and alert me if they found a hijack?
Well,
is this a service?
Yeah, there are services actually who can do it, or you can hire someone. But I would say that in the moment when someone has hijacked your prefix or autonomous system, there are also two things of what can be hijacked, then it's too late already. Of course, it's better to get informed about it, not from the newspapers and media, but like from your consultant or monitoring service. But I would say it's too late already. So your homework, which has to be done, is before you get hijacked. At the moment, without those steps 4 and 5 or our proposal, globally, all of us are on the ice. It can happen with any one of us if the larger players, like Rostelecom, Deutsche Telekom, or someone else, does it for some specific reason. Unfortunately, you will get influenced. So it depends. I would say the answer is depends.